Hey guys, welcome to our next lesson on data, where today we are looking to determine range, an inner quartile range, which we're going to shorthand as IQR, from a data set. Inner quartile range is likely to be new to you now in Year 9. Starting with the warm-up though, I want you to find the mean, median and mode for this data set here, where I've already arranged the data set in ascending order for you. So today our title is Measures of Spread. Okay, so that's literally what it sounds like. It's how spread out the data is. So we're going to consider our warm-up data set, and we're going to consider this smaller data set here. And if I was to ask you which data set is more spread out, you would be able to look at this and likely tell me that the answer is this data set up here. What you're likely doing is considering the range of the data set. The range of the data set is quite simply the maximum value in the data set minus the min value. So in the case of our warm-up problem up here, the range is equal to 13 minus 1, or 12. This means that the data set spans 12 values. This one here, for example, though, the range is much smaller. It's 7 minus 4, which means the range of this data set, even though it's got 6 values, it actually only spans 3 total numbers, or 3 total integer values, which is pretty cool. So it's really easy to see which type of data is more spread out by simply looking at the range. But this means that if we were, for example, to have a number over here, and say for example I then had the number 100, this means that the range for this second data set would be really skewed. Okay, and it's not really true of these first 6 numbers. And it shows that this data is much more spread out, even though this might just be considered a huge outlier. Which brings us to what we call inner quartile range. Now, the inner quartile range is to do with the middle of the data set, or the inner parts of the data set. We calculate it as follows. The IQR is equal to Q3 minus Q1, where Q1 is the median of the lower half of the data, and Q3 is the median of the upper half of the data. And I know that doesn't make a lot of sense yet, but it will when we do an example. That makes us question, well, if there's Q3 and Q1, what is Q2? Q2 is actually the official name or the official abbreviation for the median of a data set, which is the middle value. If there's an odd number of data points when we consider our lower half and upper half of a data set, that means we just remove the median before we calculate Q1 and Q3. And we have an example of this on the next page. Here we go. So I've got 2 data sets here for you. All right, data set A and data set B. All right, now in each of these cases, I've already put them in ascending order for you, but if that is not done, you will have to put it in ascending order yourself. Now, when we're calculating the inner quartile range, we need to calculate Q1 and Q3. This is the median of the lower and upper half of the data. So the first thing you want to do is you want to go ahead and you want to find the middle of your data set. So I'm going to do this like this. I'm just working my way to the center, and I notice that the middle of my data set is 7 and 9, and I'm actually just going to split it in half, and I like to put a nice big thick line there. Now, if I'm looking at the lower half of my data, Q1 is the median of the lower half of my data, and I can see that the middle number there is 3. So Q1 is simply equal to 3. For the upper half of my data though, okay, it's a bit different. I've still got 5 numbers, and if I look, I can see that my middle number is 12, which means Q3 is equal to 12. And now an inner quartile range is simply equal to Q3 minus Q1. So in this case, it's 12 minus 3, or 9. So the inner quartile range for this data set here is 9. Now, what does the inner quartile range actually tells us? It's basically just the range of the middle values of the data set. So in this case, we have a pretty big inner quartile range with spanning 9 values, but we can still see that that's smaller than the actual range of 12. The other thing about inner quartile range is it's not skewed by big outliers like range is. So if you consider what we talked about at the beginning of the lesson over here, if we were to include a really big outlier over here, our range would increase by quite a lot. That doesn't happen with inner quartile range. It's just talking about the middle values of the data. So it's another way to help measure spread. Let's have a look at B. In this case, we want to find, to begin with, the center of our data. So if we just work from the outside to the middle, I can see that I have a true median here. Now, if we go back to our rules, it says if we have an odd number of data points, which means we have a clear median, remove the median before calculating Q1 and Q3. So in other words, I'm just going to pretend that that's not there. I'm just going to put a box around it, and that box is sort of going to act like a line, like over here, for my lower and upper half of the data. And my lower half of the data is here, which shows me that my Q1 or median is 5, the middle value, and my Q3 up here is 7. So the inner quartile range for this set of data, Q3 minus Q1, is equal to 2. So let's move to a textbook example now, where we've been given a little bit of context. We are given a set of measurements collected by measuring the lengths in meters of 10 long jump attempts. So we have 10 different values here. So the first thing we're asked to do, obviously, is to list the data smallest to largest. We then want to find the range, find Q2, Q1, Q3, and hence the inner quartile range. And then once we have that value, we want to interpret it. So feel free to pause this and have a go at this now, otherwise we'll work through this together. The first thing I'm going to do is reorder the data set. So I've done that already, so I'm just going to write it down. We've got 5.1, 6.7, 7.1, 7.9, 8.2, 8.3. I'm running out of space, so I better move this guy somewhere. Oh dear. Somewhere where I actually have some space. That's not going to work. That's all right. We'll just rewrite it down here. A, 5.1, 6.7, 7.1, 7.9, there we go. Finally ordered. Now we want to find the range of this data set. Okay, so I'm just going to delete this here. The range of the data set, R, will be max minus min, okay, which is 9.2 minus 5.1, which gives us a range of 4.1. So that's how we would answer B. To answer C, finding the median, well, let's work from the inside out. All right, we've got these values, and we notice here we go, that our median Q2 is going to have to be the average of these two values here. So that's 8.2 plus 8.3 over 2, which is simply 8.25. Okay, CI. Now to get the lower quartile and upper quartile, and hence the inner quartile range, I'm going to do what I did before, and I'm going to split my data in half. And the good thing is when I have an even number is my data splits in half quite nicely. So you really have a bit of an option here. You can choose to split your data in half nicely like over here, or you can choose to have a really easy median to calculate. You really get one or the other. So if I split my data in half, then I'm looking for the median of the first half. I can see that that's the middle number there. So that will be my Q1. And for the second half of my data, it's here. This is my middle number, my fifth number, Q3. Therefore, to calculate the interquartile range, it's Q3 minus Q1, because remember, it's basically the spread of data, the spread of data in the middle of our data set. 8.8 minus 7.1 is 1.7. And you can see here that this value is much smaller than the actual range. And the cool thing is that if I consider 7.1 and 8.8, this is in this example, it's about the 50% of the data set, okay? Especially if I consider these four values here. So really, if I want to interpret my interquartile range, which is D, I could say it's the range of approximately the middle 50% of the data set. So that's how I would interpret that. So working with interquartile range, it's going to be easiest to make sure you pop your data out written in your book so you don't have to draw on your screen or on your textbook. So when you go to 9J, keep that in mind. Have a go at questions 1D and E, question 3 and 4, 6, 7 and 8, and question 10 if you're looking for a challenge. If you have any questions, you know you can email me.